All right, section 5.5 is titled Direct Variations. And so we're going to do a little review from last year and what we looked at. Last year we looked at proportional relationships and constant changes, and those are two different things. So I want to refresh a little bit what each one is. A proportion is just a ratio of the y values to the x values. So when we look at this chart here, for the rice, the number of cups, and then the number of servings that we get out of those cups of rice, we see that if we put our y value over our x, we get a ratio, and this ratio reduces down to 5. 10 over 2, that reduces down to 5. 15 over 3 reduces down to 5. And 20 over 4 reduces down to 5. So when that happens and we have the same number that they reduce down to, we have a proportional relationship. Now, a constant rate of change, what did I do? A constant rate of change says that we are going to have the difference between our y's and over the difference between our x's. So that proportion between the differences needs to be the same in order to have a constant rate of change. Yeah, there's a reason why I don't use this screen revealer. So 10 minus 5 becomes 5. 2 over 1, or 2 minus 1 becomes 1. 15 minus 10 is 5. 3 minus 2 is 1. And 20 minus 15 is 5. 4 minus 3 is 1. So we do have a constant rate of change between the points. So if you notice, the constant rate of change and the proportional constant is the same. And that occurs when we have a direct variation. Yay! Aren't you excited? So if you're given a table, we have to check both proportionality and constant rate of change to see if those are the same thing. If you're given a graph or an equation, you can identify if a line or a direct variation, a line is a direct variation by looking at the y-intercept. So if b is 0, then the line is a direct variation. First, you have to know that you have a line. And second, then you're going to check the y-intercept. So when I look at this equation, this first equation, if I divide everything by 3, I get 4/3 x plus 1/3. This y-intercept right here is not 1, or is not 0, so therefore it is not a direct proportion. It's just a line. I'm going to show you graphically with Desmos that I have this graph, 4/3 x plus 3. Here's the graph of it. It goes through 1/3, and it has a slope of 4 over 3. So it goes through 0.3 and 4 and 1/3. So there's that line, and so we can see that it does not go through the origin, so the y-intercept is not 0. This one, if we divide both sides by a -4, we get y equals -3/4 x. There is no plain number added on, so the y-intercept equals 0. And once again, we're going to go back to our graph. We're going to turn that line off, and we're going to look at this blue line. And we can see that it goes through the 0, goes through the origin, and it has a y-intercept of 0. So from a graph perspective, you don't have to look at the equation. You can just look and see, is it a line, and does it go through the origin? Because that's where the y-intercept would be 0. And then this last one, y equals -3x. There is no y-intercept again. So the y-intercept is equal to 0. So this one, if I turn that graph off and turn this one on, it goes through the origin once again, and it's a line. So we do have direct variations with these last two equations. Okay, so we can tell from a table by calculating out the proportionality constant and the constant rate of change whether or not we have a relation. You could put those points into your graphing calculator and plot those points and then connect them with a line to see, does that line go through the origin? Is it a line? And or if you're given a graph, you're gonna see that it has that it goes through the origin or not from the graph. So all three of those ways. Now we do have one other thing that we have to talk about, and it is the dreaded story problems. Yay! So I'm going to move these little things because I want to be able to type. So I'm going to go up here and type now. And we're going to type this problem. The three-toed sloth is an extremely slow animal on the ground. Oops. On the ground, it travels at a speed of about 6 feet per minute. Write a direct variation equation for the distance y a sloth will travel in X minutes, then graph it. Okay, so they're telling us right away that it's a direct variation. So we know that the question is, what's our equation? Well, we know that we have a y-intercept of 0, so it's just going to take on the form of y equals something x. And the constant of variation, that number in front of the x, the slope, is going to be its rate of speed, 6 feet per minute. So y equals 6x is the equation that we're doing. And we could verify this by making a table. If we put zero, if the time is 0 minutes, he traveled 0 feet. 1 minute, he traveled 6 feet. 2 minutes, he traveled 12 feet. 3 minutes, he traveled 18 feet. So we could make that table. We can plot that out. We have a y-intercept of 0, 1, 2, 3, 4, 5, 6. A slope of 6, 6 over 1. There's our graph. Or we could plot those points if we didn't want to use the slope intercept. So those keywords of direct variation tell you don't have that your y-intercept is 0 and that your constant of proportionality is going to be your rate that you're talking about. So there's one other type of there's one other way that they can do the story problems, or they can present the story problems, I should say. And it's with a statement that is like this. The value of y varies directly with x, and y equals 1/2 when x equals 3, find y when x equals 1. Okay, so because we know that it's a direct variation right there, we know that we're going to have a y-intercept of 0. What did I do? I have to do my undo on my back. Let me retype that. It's just going to be easier. Sorry, guys. Okay. Try this again. Thanks for bearing with me. When x equals 1. Okay. So now I'm going to get out of my text so I don't retype over things. So varies directly, and that's going to tell us that we have that y-intercept of 0 and just y equals our constant of variation times x. And we can find our constant of variation by taking the ratio between our known values. When y is 1/2, when x is 1/3. So we find our constant of variation by taking that ratio. 1/2 divided by 3. Well, you have to remember that this is your main division line. Division is the same as multiplying by the reciprocal. The reciprocal of 3 is 1/3. So our constant of variation for this problem is 1/6. So once we have that constant variation, that's also our slope. So our equation is y equals 1/6 x. Here's our equation. Now we plug in that x value equal to 1. So y equals 1/6 times 1. And y equals 1/6. Okay. So that is the other way that they can present it in words. You create your constant of variation from the given points, plug it into your equation. Remember, you're not going to have a y-intercept because varies directly. So it's just that simple equation there.